Welcome back, everyone. And in this lesson, we're going to use that new Cura slicer that we downloaded. And we're going to make G codes for this inkwell so that we can print it. All right? So, what we're going to do is first, I brought up in Fusion 360, I brought up my model. This was project 5A in week 5, so you should already have this one done. And I am going to print this or make a G code so that I can print it. Alright, so the first thing that I do is I want to make this an STL. And you guys remember how to do it. Just go over here to File, go down to 3D Print. You can actually do an export, but I'm going to go to 3D Print on this. And on this 3D print, I click on it. Make sure that I am in millimeter. Preview mesh. And also refinement. I want a really high refinement so that my triangulations can be really tight on this, because there's a really thin lip on this inkwell. Okay, so it has to be a really tight bond there. And I'm going to turn off send to 3D print utility and hit OK on this one. And of course, I'm going to send this to my DPT 100, and I'm just going to type in inkwell STL file. So now I've got my Cura slicer up. All right. So when I bring this up, there's a lot of cool things. This right here, I put it in isometric. You can look at it from the front, top, side. And the first thing you want to do is whatever 3D printer you're going to print to, you need to set that up. And we already set that when we first started with the Artillery Sidewinder X1. So if you need to add another printer, you can add another printer, okay? And I'm going to go ahead and do that right now just to show you how it's done. But, of course, I don't have these set up on a network, so I go to non-network. I want, maybe you have another popular ones like MakerBot, something like that. If you are using a MakerBot, you can click on it, choose which one you're using, and add it, and see how you've got now. You've got the different ones. You got your Sidewinder, you got your MakerBot. So again, we're using Artillery, but that's how you do it. That's the first thing you want to do, is make sure that you are utilizing the correct printer. Now, the next thing after that is right here, you've got generic PLA. That's what kind of material we're going to be using. And PLA is, in my opinion, in FDM 3D printing, it is the most easy. It's the easiest plastic to use. Okay, it's the easiest material. Seems like it doesn't have a lot of shrinkage, and it has a lot of great properties, and it really produces a great part. And it just depends on what you're doing, but for larger parts, it does really well. So that's what we're going to be using to start out with. 0.4 millimeter nozzle, that is the standard nozzle in FDM 3D printing. So, and sometimes there's a little bit different ones that's out there, but 0.4 is the standard. Now the standard quality, and we get over here, there's different quality levels. All right, and in that we're using 0.2. That's how thick the material is printing. I mean, you can go down to a 0.12. Just you have a lot more lines. So we're just going to use 0.2 to start out with. The infill is, do you want this part to be solid? If you want it to be solid, come over here to 100. You see how the infill, it'll be solid, which it takes a lot longer and a lot more material. If you do 20, it'll have an infill. It just, the outsides will look, it'll be exactly the size of your part, but you're going to have a like a honeycomb look on the inside, and we'll see that in some of our projects a little later on. But for this project, basically, we're going to use 100% solid on this because the walls are so thin on this that we're going to have to use 100%. Okay? The next thing we're going to do is click on our support and then also adhesion for this. Okay? And the adhesion, like it says here, it prints a brim or raft that will add a flat area under your object, and then it'll actually peel off. Now, what that's doing is, one of the major things with 3D printing is having your bed level on an FDM machine. Okay? If your bed's not level, you'll have all kinds of issues and problems. I mean, it has to be perfectly level, and there's all kinds of ways to level these. It just depends on your machine. But you've got to make sure it's level. Well, to make sure, if you're just printing on something you've never printed on before, you haven't, leveled it, you don't have the time. If you print you a raft underneath of it, you'll not. It'll actually level it for you, so you'll know that you're nice and level. But sometimes, if your bed isn't level, your raft will pop loose. One of the edges will pop up. And that's the last thing that you want. So, of course, make sure your bed is level before you start printing. And then support, if you have things that are overhanging, it'll actually build a support under it. And we're going to talk about some of that a little bit later on in class. So, for this first one that we're doing, we're going to use 100% infill. It's going to be solid because it's got that thin wall. We're going to use 0.2 on the thickness of the material being laid, and that should be great. So next thing I want to do is I want to come over here to the folder, and I want to open up that project. Okay? So let me go in here, and I'll find it. DPT 100. My STL file is Inkwell. Open. And there it is. Now we have the part on here. It's going to be really important that you have put it in here and it's scaled accurately. Down here it'll tell you the dimensions of the part. This will help you to see if it's been brought in accurately or not. These are in millimeters. That's what we designed it in. So I've seen it before. People draw something in standard inches and then convert it, and it'll print millimeters. Well, it's going to be totally different in size than what the part actually is, or vice versa. You draw it millimeters and it's in inches, or even if it's in millimeters, sometimes you see centimeters. So make sure that it's scaled right, and you've got lines here to help you to see that, this little grid. Also, make sure that the part, if you click on it, just click on your part, click off of it, it goes off. But if you click on it, you can actually have a move. And all you have to do is just grab your grips here, and you can pull it. There's no use to pull it up because it needs to be flat on the build plate. I can just move it around. And the thing of it is, what is really handy to remember is, it's all the time when it comes in, it's mostly going to go toward the center. Well, let's save your build plate. Now, this is called a build plate. I often call it a plate, or a bed. You hear that all the time, but it's a build plate. But you're always good to keep moving your objects, your parts. Now, don't go past, the lighter color here. Stay inside of it. But what it does is it saves from wearing out your build plate as fast. If you just continuously are moving your parts to different areas of it, you don't concentrate and build on that one spot all the time, and eventually you're going to wear that out if you do that. So that's a good tip for you guys on this. Make sure that the build plate is level. We talked about that. Also, the part needs to be in its best orientation so that is ease of printing. Now, if it didn't come in here flat on this, you have a rotate right here. And you can rotate this part, however you need to rotate it, okay, to get it flat. But I want to be on this flat here, so I just reset. So I want to be right back on that flat. So you have that option, if you want to use it. So I'll go back to my isometric view. You also can click on it and go to scale. And this portion of it, you can scale the object larger or smaller. But I want to go back to my original. And the other three areas, we'll get into those a little bit later. But for now, this looks great. I'm just using my wheel on my mouse to scroll in and take a look. And then you can take and smash your wheel down to pan around a little bit. Everything looks good. We got our printing settings ready to go. Everything looks good. And I want to come down here and hit slice. And it's slicing it right now. All right. So it's going to take me 1 hour and 57 minutes to make this. It's going to take 18 grams of material. So that way you can calculate how much material you're using, okay, whenever you have to order and buy material. One thing you got to realize too, we're doing 100% infill. That means this part is going to be solid. If you have an object where it doesn't have such a thin little layer like we have, it's a big part, you can go more sparse with it in your infill, and it would be kind of hollow, like it got a honeycomb inside of it, and that reduces your time and materials, okay? So that's one thing to think about, and we'll do another part in the upcoming days, and you'll see that. So 1 hour and 57 minutes, basically 2 hours to do this, and you can hit preview right here if you want to take a look at this. And you all see it when I hit preview? See right here, it's showing you, this right here, of course, is that raft, that adhesion raft on the bottom of it. And for support, it didn't have to have any support because we laid it out perfectly. And the thing of it is, on the inside, you're not going to have support just because on this one here, on the inside of it, it's going up at an angle. You have radiuses, and it can build on top of itself. There's nothing really overhanging that it needs some sort of support. Now, I want to show you with this preview on, over here to the right, you can actually come in here and cut it and look at how this thing is being built. You see that? So as it's being built, there's the raft that it begins on, down here in the bottom. And then here we go. It takes off and starts building. And you all see the walls coming up. It'll keep building, and then it starts to do the curve and goes to the top. And there's your part. So what I want you guys to do, and of course, is save this somewhere, okay? Save to disk, save to removable drive. I've got my E drive in, a flash drive. It's just going to let me take that flash drive and go straight to the machine and plug it in, and it's ready to go. So I want you guys to do that, save it, and it's building the Gcode right now. I'll come in here and do snipping. And what I want to do here is I want to take a picture of your part, okay? And file save as, and take it somewhere where you can access it. This is DPT 100 Project 7B, and this is the Cura slicer. I'll put 1, save. So I got that part image. Oh, I didn't have enough space on my E drive, so I'll have to save it to something else here in just a little bit. But also, I want you all to pull this thing down a little way so you can see inside of that, and I want you to do another picture for me. Okay? Snipping tool. and we'll do us another little shot of it. I was changing the last to 2, so I know where it's at, just for future reference. And again, you want to save this. You want to have enough room on your disk to be able to save it onto. But I want you to make sure that you get a picture of this, and also get your Gcode file saved. And I'll show you in another video how I want you to submit all this. Okay? So if you have any questions, just let me know.